Hello students, welcome to the first lecture of the lesson number system. In segment A, we have done the lesson number 1 in mathematics, which is known as rational number, the part of number system. Right? So today also in segment 9, we are going to learn lesson number 1, which is known as number system, and the lesson from standard A, which is rational number, is a part of the same topic of standard 9 number system. So in this lesson, we are going to learn some more topics of the number system. Okay, so starting from this, let's have a look on some types of numbers. Some types of numbers occurs into the number system. The first number is natural number. Okay, so what do you mean by natural number? Natural number means what? Natural number is the number which starts from 1, 2, 3 and so on. Means what? See, natural numbers are numbers starting from 1, 2, 3, 4 and it continues to the nth term. So, numbers starting from 1 is known as natural numbers. Okay. Next, whole number. What do you mean by whole number? Whole numbers are the numbers which starts from 0. Whole numbers are the numbers which starts from 0. Starts from 0 means what? Whole numbers are numbers which are starting from 0, then continues to 1, 2, 3, 4 and so on up to the nth term. So natural number starts from 1 and whole number starts from 0. Integers. Integer means what? We have learned there are two types of numbers. Some numbers are positive numbers, some numbers are negative numbers. So combination of positive number, negative number is known as integers. Means all positive numbers and negative number along with 0 are included in integers. Means minus 3, minus 2, minus 1, 0, 1, 2, 3, so on. All such numbers are known as integers. Okay guys? Now, rational numbers. Rational number, definition of this rational number we have already learned in standard 8. Just let's record it. Rational numbers are the numbers which can be written in the form of P upon Q. Means in the form of fraction where denominator cannot be equal to 0. Right? So, rational numbers are numbers which can be written in the form of P upon Q, where Q is not equals to 0. Q is not equals to 0. Okay? If we talk about decimal expansion, means if we convert any rational number into a decimal form, then the decimal expansion of rational number is always terminating or non-terminating recurring. Means what? See, decimal expansion is terminating or non-terminating but recurring. What do you mean by terminating and non-terminating recurring? See, I am taking example of rational number. Let's have a look. Example: 2 by 3, 4 by 5, minus 7 by 6. All these numbers are included into the rational numbers, right? But decimal expansion of such numbers, just like 0.14144 or 2.3, what is happening? This decimal expansion means decimal form of these numbers is stopping, ending at a particular point, at a particular state. So these numbers are rational numbers. 0.144 can be considered as a rational number. 2.3 is considered as a rational number. Or we can say 1.33333, so on. It is continuing. What is happening? This number is continuing. 3 is continuing repeatedly. This 3 is coming repeatedly. Means this number is non-terminating. Means this number is not getting end at anywhere. This is continuing. So this number is called as non-terminating, but it is recurring. Recurring means that pattern is repeating. See, 3 is repeating continuously. 3, 3, 3, 3, 3, 3. It is repeating continuously. So this number is known as non-terminating but recurring. Means its part is repeating continuously. So such numbers are known as rational numbers. Such numbers are known as rational numbers. Now, irrational number. What do you mean by irrational number? It is opposite to rational number. Means rational numbers are numbers which can be written in the form of P upon Q. But irrational number cannot be written in the form of P upon Q. Okay? So irrational numbers are numbers which cannot be written in the form of P upon Q, where Q is not equal to 0. These numbers cannot be written in the form of P upon Q. Okay? Then, if we look at decimal expansion, so decimal expansion of irrational numbers is non-terminating, non-recurring, non-terminating, non-recurring. Non-terminating, non-recurring means what? See, I am giving you example. 2.134578943, and this is going to continue. What is happening? This number is known as irrational number. Why? Because if we look on the decimal expansion, decimal form, there is no particular pattern is repeating over here. Just like in this decimal expansion, a particular pattern of 3 is repeating, 3 continuously. Here, it is not stopping anywhere, so it is non-terminating. Secondly, this decimal expansion is not ending anywhere, and there is no particular pattern is continued in this decimal expansion. If I look upon one more example of this rational number, 2.363636, or we can say for repeating numbers we can say 2.36 bar. What is happening? This 36 is repeating continuously, so this number is known as rational. But there is no particular pattern repeating over here. Therefore, this pattern is known as irrational numbers. Such numbers are known as irrational numbers. Okay. One more thing. Square root of non-perfect square number. Non-perfect square number is irrational number. Is irrational number. Square root of what? Non-perfect square number. What is even non-perfect square number? A number who is not a square of any number. Means, just example, consider 5. 5 is not a square of any number, so it is non-perfect square number. 9 is a square of 3, so 9 will be considered as a perfect square number. 2 is not a square of any number, so it is non-perfect square number. So square root of 2 will be known as irrational number. Square root of 5 will be known as irrational number. Square root of 15 will be considered as a irrational number. So example will be root 2, root 3, root 7, and so on. You can consider anywhere. Okay guys? So these are the all types of numbers which we have to use continuously, particularly in this lesson. Okay? Now I request you all to pause this video and note down whatever I have written on the board into your copy. Then we will continue this video. Okay guys? So kindly pause the video to note down everything from the board. So students, now we will learn how to find out rational number between two rational numbers. Now we are going to find out rational numbers between two rational numbers. Means if there are two continuous numbers and we have to find out some more numbers between that two numbers. How to find out? Let's have a look. See guys, this concept we have already learned in standard A to find out rational numbers between two rational numbers. But there are some more questions based on this topic in an NCERT exercise 1.1. So let's revise this topic again. Okay? Let's have a look. See, finding rational numbers between two rational numbers. See, find rational numbers between 4/7 and 5/7. We have to find out 5 rational numbers between 4/7 and 5/7. If this is a number line and if this is 4/7, then after the next number is 5/7, right? So on number line, it looks like these two numbers are continuous numbers and there is no such number in between these two numbers. Then if there are no such numbers in between these two numbers, then how can we find out 5 rational numbers? Yes, we can find out 5 rational numbers between these two numbers, but there is a method to find out rational numbers. See, 4/7 and 5/7, let's multiply numerator and denominator of this both number by 10. Multiply by 10. So 4 into 10 upon 7 into 10. And here also in second number also 7 into 10 multiply 5 into 10. Right? Now 4 into 10 becomes 40. 7 into 10 becomes 70. And 5 into 10 becomes 50. And 7 into 10 becomes 70. Means what we have done? We have made the denominator equal, first thing. And we have multiplied by same number to all. Therefore, these numbers are equivalent to the original number. These numbers are equivalent to original number. So, now between 40/70 and 50/70, there are 10 numbers. Which are they? 41/70, 42/70, 43/70, 44/70, so on up to the 49/70. So we can pick any 5 numbers. Let's pick 42/70, 43/70, 47/70, 48/70, 45/70. These numbers lies between number 4/7 and 5/7. Okay guys? And this is the method to find out the rational numbers between two rational numbers. Okay, now let's have a look on one more example. Find three rational numbers between minus 2 by 5 and minus 3 by 5. Three rational numbers between minus 2 by 5 and minus 3 by 5. Minus 2 by 5 and minus 3 by 5. If we represent on a number line, it will be minus 2 by 5 and this will be minus 3 by 5. These numbers looks continuous. And there is no such number between these two numbers. But we have to find three rational numbers. So how to find out? By same method. See, minus 2 by 5 and minus 3 by 5. What we will do? We will multiply by a particular number to all these numbers. Let's multiply each by 3. Multiply each by 3. So it will be minus 2 into 3 upon 5 into 3 and minus 3 into 3 upon 5 into 3. So it will be minus 2 3s are 6 upon 15. Minus 3 3s are minus 9 upon 15. Now between minus 6 upon 15 and minus 9 upon 15, denominators are same. Now we can find out the remaining numbers. How many numbers between minus 6 upon 15 and minus 9 upon 16? 15. There are numbers which are minus 7 upon 15, minus 8 upon 15 and minus 9 upon 15. These numbers are numbers which lie between minus 2 by 5 and minus 3 by 5. So we will write minus 7 upon 15, minus 8 upon 15 and minus 9 upon 15 lies between numbers minus 2 by 5 and minus 3 by 5. Here also we will write these numbers lies between 4 by 7 and 5 by 7. Getting this nice? This is how we will solve such kind of question. Okay. Now I request you all to pause the video and note down these two examples from the board. Now students, let's have a look at some more examples on the same question. Find the 5 rational numbers between 7 upon 8 and 7 and 8. 7 and 8. These are rational numbers. Yes, 7 and 8 are rational numbers. How? See, 7 can be written as 7 upon 1 and 8 can be written as 8 upon 1. Right? Now, 7 and 8, there are no such numbers looks in between 7 and 8. But we can find it out. How? See, and we have written 7 as a 7 upon 1, 8 as a 8 upon 1. Multiply each by 10. So it will be 7 into 10 upon 8 into 10. And so 1 into 10. And 8 into 10 upon 1 into 10. So number becomes 70 upon 10 and 80 upon 10. Now there are 10 numbers between 70 upon 10 and 80 upon 10. Which are they? 71 upon 10, 72 upon 10, 73 upon 10, till 79 upon 10. So we can write any number. So we will write 72 upon 10, 74 upon 10, 76 upon 10, 78 upon 10, 79 upon 10 are numbers lies between 7 and 8. Right, next? Now, find the time rational numbers between 2 upon 3 and 3 upon 5. Now, this is very important and interesting topic. Here, see what we have to do. We have to find a rational number between two such fractions whose denominator is not equal. So, how to find out the rational numbers between these two rational numbers? See, 2 upon 3 and 3 upon 5. Here, what we will do? We will make denominator equal. Okay? So, how to make denominator equal? What is the LCM of 3 and 5? LCM of 3 and 5 is 15. LCM of 3 and 5 is 15. So, what we will do? We will multiply these 3 by 5 to get 15. So if we are multiplying denominator by 5, so we have to multiply numerator also by 5. Here 3 upon 5. Here also we have to multiply to make LCM is 15. right? So LCM is 15. So to get 15, we have to multiply 5 by 3, and we have to multiply 3 by 3 also. Why? Because as we have multiplied 5 by 3, so we have to multiply the numerator also by 3, means by the same number. So the number becomes 2 5s are 10 upon 15, and 3 3s are 9 upon 15. Right? Now this 2 upon 3 and 3 upon 5 gets converted into 10 upon 15 and 9 upon 15. Now what we have to do? We have to find out 10 rational numbers. So how can we find out 10 rational numbers between these two numbers? See. Now we will do one thing. We will multiply each by 20. Each by 20. From where the 20 comes, I took it by myself. मैंने अपने मन से लिया. You can also take any number to multiply. Okay. Now we have multiplied by 20. So 10 into 20 upon 15 into 20 and 9 into 20 upon 15 into 20. So it will be 200 upon 50 to the 30, so it will be 300. 200 upon 300 and 92 is 920 is 180 upon 300. Now we have a number 200 upon 300 and 180 upon 300. So 2 upon 3 and 3 upon 5 becomes 200 upon 300 and 180 upon 300. Right? Now the denominators are equal, and on numerator there is a number 200 and 180. So between 200 and 180 there are 20 numbers, out of which you can write any 10 numbers from between these two numbers. So let's write 182 upon 300, 185 upon 300, 192 upon 300, 197 upon 300, and so on up to 10 numbers. How many numbers? 10 numbers between 200 and 180 you have to write. And this is how we will find out rational numbers between two rational numbers. Okay, so guys, complete these numbers, write more. I have written 4 numbers, write more 6 numbers and solve it by your own. Okay, so this is how we will find out rational numbers between two rational numbers. I hope you understand this topic very well. Now I request you all to pause the video and note down these things from the board.